All right, welcome to Open Office Hours. This is July 10th, 2025, and tonight we'll be following up from our class from this week, talking about normal distributions. So I'm trying to figure out, never mind, I think I got it. It looked like I was turning like this. I think the camera was just turned askew. It's also got a, oops. Also got a lot of stuff in the back. As you see, I am, as always, checking my sound. I'll make sure that my sound is okay. And I got to work with my camera. I think it was moved today accidentally. So anyway, we're going to be talking about normal probability distributions, continuous distributions. And I'm just going to run through a myriad of problems tonight to follow up from last night. I think we had a great class last night. I think that we went from point 0 to point 100, which is where I want us to go. And I feel good with what we did. So now I'll do follow up. And remember, we're going to have two quizzes next week. One's going to be on the normal distributions that you've been assigned for the week. I will do a working session tonight and a working session Tuesday if you have any questions. Again, a quick turnaround for tonight, just like I said in class. So you probably haven't engaged with the problem since yesterday's class. But by next Tuesday, hopefully you will have done that already. And you'll have questions for me, or at least point me in the direction to make sure, double check your answers to make sure you're doing it correctly. And then we'll have a quiz next Wednesday night. That'll be a quiz on normal distributions, computational quiz, not a vocabulary and symbology quiz like we normally have. And then we'll also have a second quiz for a little bit of makeup points on the previous test. Previous test was not exactly where I wanted it. The overall average was a 62. We did have some good scores on it, but we also had some very poor scores, so it kind of balanced out. So I want to be able to give you a chance to make up some of those points. So I went back over binomial distribution last night, went through at least one of them from the test. What I'm going to do is I was telling somebody last night in class, I can't remember who I was talking to. Might have been Tiante, but we were talking about what types of problems can we work for this. I'm going to put some problems in the Moodle. I'll load up a set of types of problems that you need to work on. And then if you have any questions on those, I'll certainly take those during online office hours as well. And hopefully that helps you get back in the ballgame. I got a little bit too much of a poof on my hair. So hopefully that'll get you back in the ball game next week. And then, of course, we just have a few weeks left in this summer session. It's a pretty quick turnaround. So as you see, I've got my normal probability distribution sheet up here. Let's just go ahead and get started. And I'm going to keep it on the main screen until we get to the point with the calculator, and then I'll switch screens. Then I'll probably have to adjust because I am using Mirroring 360. And whenever I adjust anything or move anything to another screen, sometimes that shifts over. I have to readjust it. So, all right, real quick before we get into it, I know a lot of people talk about their streaming. I know on the gaming side of the house, they always say, this is my PC, I built it, and it's got all this in it. I stream from an older 2015 Mac. I stream using Ecamm. I like Ecamm a lot. I probably don't maximize all the benefits from it, but I do like Ecamm. Months ago, I used Doceri on here from my iPad, so I was actually opening Doceri on the iMac and bridging from my iPad to there and writing on that. Worked well, but it ate up a lot of resources on my computer. So now what I do is I use Mirroring 360, and I mirror this, where you see normal probability distributions, this keynote that has all what I'm going to be working from. I stream that through Mirroring 360. I also stream my calculator, which I finally got to where it's able to be viewed here and the numbers aren't so small. So I think I'm a whole lot better off with that. And that's it. And I just stream to YouTube. I used to stream to Twitch. And the reason I like YouTube or Twitch is because my students can easily get in, get out. You don't have to sign in using your student login, which easily gets forgotten and things like that. You just sign in from anywhere on your phone and the whole 9 yards. So it's a lot easier to get in and out. I leave these videos up for the class in case there's anything useful for the students afterwards. And that's whether it's an answer to questions or answers to the things that, the examples that I'm working. Okay. And I haven't streamed for over a week or so, and I apologize to my class. It's just been kind of a busy summer, and I have just not been able to get up here for about a week. I was doing really good there twice a week, which is what I like to run it at, Tuesday and Thursday at a minimum. But now I'm finally back up here. So let's get started, and let's see what I've got on my fancy PowerPoint. Fancy keynote. Okay. My big head is in place of a little bit of that, but given the mean of a normal distribution, how can you find the median? Well, if you remember, and you guys did a great job last night remembering from empirical rule discussions on the normal curve, that the mean, all the measures of center are right there together on a normal distribution. You got the mean and the median and the mode all there in the same place right in the middle. What's the total area under the curve? 1. Describe the inflection points on the graph of normal distribution. We didn't go into detail about that, but that's where the graph changes direction. It's if you go out 1 standard deviation from the mean and you go up, that's where it starts really changing the direction from one, either going up this way or down this way. At what x values? That'd be at 1 standard deviation away. Okay. What's the mean of a standard normal distribution? The mean of a standard normal distribution is simply, let me start right. The mean is 0, and the standard deviation of a standard normal is 1. Remember, we worked with this exclusively last night, and if you have a normal curve with typical data, you have to push it into a standard so we can work with it using our tables or using our calculator. Explain how to transform a given x. I wrote that. I did it again. It's that and it's that. I'm sorry about that because my head is in the way here. I need to readjust this screen and put me down at the bottom. Explain how to transform a given x value of a normally distributed variable into a z-score. And if you remember, it's just z equals the x value, subtract the mean, divided by the standard deviation. We did plenty of those last night. I'm going to do a few more here and make sure we're all on the same page. Excuse me. All right. What a beautiful picture. This is from GeoGebra. In GeoGebra, you can bring this up and I can adjust it anywhere I want to. So find the area of the shaded region under the standard normal curve. So last night we were working with all numbers. I was drawing some very poorly drawn sketches, but I was drawing illustrations. I was actually superimposing over the top of a very nicely drawn normal graphic. But on this one, we've got a picture and we've got the... Hey, Artemisia, thanks for coming by. Just going through some problems here from normal curve last night, a little bit of discussion. So it says, find the area of the shaded region under the standard normal curve. Well, if you look here, and of course, you probably need a little bit more defining, but this looks like it's definitely going far enough out to the left that we can think of it as going to negative infinity. So we are, use a little darker color here, probably. We are trying to find the area from this negative 1.5 all the way back to negative infinity. Okay, so how are we going to find that? Well, if we had our tables, we would use our tables. And let me go ahead and switch screens here. Let me see if I can this will put my head down at the bottom. There we go. Hopefully you can still see this, the graphic. Certainly my head being at the bottom is a whole lot better because it's much less of me in the picture. But we need to find the area of the shaded region under the standard normal curve. So if you have your table, in fact, that's the one thing I forgot to bring into the picture today. Is the graphic of the table. I could probably bring it up. Take me a second. Give me 1 second. Here we go. Okay. So what I've got here is my standard normal distribution. Table values represent the area to the left of the z-score. This is from any standard class. There are different ways to represent this table. You can find them online. You can find them in the book. My class has a copy of this already. I don't think I put one up in the Moodle yet. I don't think I put it up there yet. So I'll do that when I put up the examples of binomials that you can work for next week's secondary quiz. Okay. What I need to find is I need to find just the area to the left of negative 1.5. Well, this table gives me that. So I go to the table and I go to the negative side and I'm at negative 1.5. So it's 1.50. So I got 0.06681. So I've got 0.06681. And that's what I get for the area to the left of the z-score, negative 1.5. Okay, no problem. Now let's look at it from a calculator stance. I'll try to do both of these, and I certainly apologize again for not having the graphic up. When I use Restream limits me too on how much stuff I can put up there. The problem is I don't have enough room on the screen. But typically I can switch between things and then minimize it, so I'll try to do that. Maybe I'll use Restream next Tuesday. Anyway, so let's talk about the calculator. And let's go to second vars. Let's go to second vars. There we go. And we are looking for normal CDF, because remember this is a continuous function, so we're looking at the cumulative density function. So we're looking at normal CDF. It's the second choice down. This calculator is my $4.99 calculator through Apple that I bought, so I just have it forever. I like it. It's the same as your TI. It just slightly looks different when you get to these pages. But there we go. So I got normal CDF. Now remember, in class I always make the comment that there's more than one way to skin a cat. If you look at the syntax below where it says normal CDF, it has lower bound, upper bound, mean, and sigma. Well, we're already working with the standard normal curve. So instead of putting all of that up there, I don't really have a lower bound and an upper bound with data necessarily, with a specific mean and sigma. I'm working with the standard already. So what I'm going to do is just go from my farthest left point. So find my z-score to the farthest left, and I'm going to find the z-score to the farthest right. And I'm going to tell the calculator to find the area in between these two. I always find that's the easiest way to represent it. So in the case of this, we're going out to negative infinity. But in class, I told you arbitrarily, just use negative 10 on this side and use 10 on that side as a far point. For the reasoning of 10's just easy to remember on each side. I think I told you last night I've had some classes where we went negative 5 and 5, which is plenty as well. But people would forget 5. They didn't know the significance of it. The significance of this is only that I choose that for the class. That's it. It takes us far enough out without having to go to a million, trying to get as close to infinity as we can, because it's going to be the same. So I'm going to go from negative 10, comma, to negative 1.5, and we'll see if this, yeah, there's the answer. And it says 0.066807, which is the same as 0.06681 from the table. So I've got it. I'm good to go here. So there's the calculator. And my view on here, although you couldn't see what I was doing, I was looking at my table. Okay. Another example, and in this one, I don't know if you can see this because of my color scheme, but this is another standard normal table where the mean, standard normal, so the mean is 0, standard deviation is 1. And what we're trying to find here is the area of the shaded region under the standard normal curve. Now let's take a step back for a second. I didn't do this on the last one. But what we're trying to find here is the probability that z is less than 0.6. So if I write it out symbolically, that's what I'm looking at. The probability that the z-score is less than 0.6. Okay, so I'm trying to find from here all the way to negative infinity. No problem. I'm going to first use the table. I'll write the answer up here, and then I'll go to the calculator, which you can definitely see. Oh, you're asking, well, we have to show our work on the quiz as far as this goes. The work that I show here is what you'll need to show. In other words, that's a real good question. In other words, I think a better question to elaborate on this is, what work will we have to show specifically? So you have to show some work. I'll define that right before the quiz because I haven't written that quiz yet. But the problems that you'll see will be very similar to these. You'll have a graphic and you'll need to find the area underneath the curve or find the probability, however it's written. So, but you may have to rewrite it. And I'll get to one in a second where it's in with x's and z's. And I will ask you to write it from the probability that x is less than, say, 32 and then its equivalency that we're working with is the probability that z is less than, say, 1.5. So, but I'll define that for you as we walk along. All the stuff that I show here are the types of things you need to show, and then before we take the quiz, I'll let you know specifically. Very good question, by the way. It didn't throw me for a loop, but it just made me think for a second, since I haven't written the quiz, how I'm going to have it set up. Okay, thank you for that. So the probability that z is less than 0.6. So I look at my table. Yes. So I look at my table and I'm at 0.6, which is on the positive side. 0.60 is 72575. That's probability is 0.72575. Now that's from the table. So now let me go to the calculator. Oh, forgot it was over here. Second vars, normal CDF. Oh, it's trying to put it in there. Second vars, normal CDF. And now I want to go, same as before, we're going to use this point out here, -10, arbitrary point set in class. If you use another number that's outside of 10 or even outside of at least 5, you'll be okay. So I'm going to go -10, comma, 0.6. There's the answer. 72575. Exactly what we've got up there from the table. So the same thing. I don't even have to hit enter on this calculator. Although it'll just show it. It won't utilize it if I hit answer. I don't think. Maybe it will. Yeah, it won't do anything. And there we go. Unless I hit enter, and then it'll actually be like a hard answer up there, and then I can use it. Then I can say divided by 2 or plus 5 or whatever I need to do. All right. Okay. I'm going to do two things with this one. This one, find the area of the shaded region under the standard normal curve. So this is the same idea. What we're looking for in this one is the probability that z is greater than 2. We can do that. In order to use the table looks to the left. So in order to use the table, what I'm going to have to do is find the probability that z is less than 2 and subtract it from 1. And that'll give me what's on the complement of it, which is on the other side. So that's what I'm going to do. I'm going to find the probability that z is less than 2 because that's what my table gives. And I get 97725. So what I've got here is 1 subtract 97725. And what is that? I don't know, about 0.3. 1 subtract, dang on it, 1 subtract 0.97725. 0.02275. So I got that from the table, but remember the table reads this direction to the left, right? But what I needed was this way. And when I use the calculator, I can use the calculator to go that way because the calculator syntax, I'm just using normal CDF, far left z-score, because we're working with a standard normal, comma, far right z-score, which in this case would be 10. Okay, so let me see what I get with the calculator. So I'm going to hit clear. Second vars, normal CDF, and then I'm going to go 2, comma, 10. 0.02275. Exactly what we got there. So, awesome. It's great when it works out like that. So the area under the curve in this direction to negative infinity was 0.97725, which remember I talked about logically understanding these curves. That logically makes sense because that's the majority of the curve. That's the large part of the curve all the way from negative infinity almost to the other side, to the far side. And so that's 97, almost 98% of the curve. On the other side is what's left, which is just about well, not 2 1/3%, so 2% basically. Okay, hope that helps. And again, if you have questions, Artemisia, I appreciate the question on the showing the work on the quiz. But any other questions, throw them out there. If anybody else comes in, just let me know you're here. I always annotate. I don't always give points, but I always give grace at the end of the semester when folks show up for open office hours. It would be just like if I was a professor up there in my office, but this is just online, so I just keep up with it. Doesn't hurt you if you don't come, by the way. Well, there we go. All right, another one. I'm going to just use the calculator to find this one this time. And what I'm looking for is all the way to infinity. So I am looking for the probability, and this is a standard normal, that z is greater than -0.9. That's what I'm looking for. Okay. I'm going to find it using the calculator. On the calculator, what I'm going to use is, let me see if red shows up. Okay. On the calculator, I'm going to have normal CDF, and the far left value as I'm facing the curve is going to be -0.9, comma, and then I'm just going to go out to 10, which represents my infinity. It's far enough out that it represents my infinity. We'll see what we get. Clear second vars, normal CDF. When I say it was -0.9, comma, 10. 0.815. So I've got 0.81594. I'll put all that out there. Okay. I am going to use the table to check this, just to see how close we are. So normal CDF gives me that. If I was using the table, now using the table, I'm going to have to find this and subtract from 1. So I'm going to have to find this number and just say 1 subtract that number. So basically I'm looking for 1 subtract the probability, whoops, that's terrible, that z is less than -0.9. No problem. So I'm going to find -0.9 on here, so I have to flip over to the negative side. -0.9, just 0.90, and that is 18,406. So it's 1 subtract 18,406, right? That's what I need to find. So I've got 1 subtract 0.18406. I did it again. 1 subtract 0.18, what was it again? 406. And you get 0.81594. Good to go. So I'm using my table again. I know you probably can't see this very well, but I'm using my table that I handed out in class. I'll load it to the Moodle. I haven't done that yet, just in case you lose this one or spill a drink on it or something. You'll have a backup. And I'm also using my calculator just to verify one way or the other. So 81% of the curve lies over there. Now, remember I was talking about logically. Well, if you remember that 50% of my curve lies on either side of that middle point, and then from then from 0 to 1 standard deviation away is about 34%. So that's about 84% total. We're coming up just shy of that -1. So that 81, basically 82%, equates to that little bit of loss that we've got. So instead of being 84%, it's 82%. Again, logically, from empirical rule and your knowledge of that, this should make sense. And that's really where I want you to be, because if you're looking at a normal curve, you need to be able to decipher it and use some synthesis to pull the data out so you can talk to the folks that you work with if you're working with data. And so I think that's a bigger skill than actually working it down to here, unless you're a mathematician and actually crunching those numbers. But I digress. All right. A different one. Now, let me tell you what I did on this one. I created it, and I forgot to put the number there, so I'm going to have to create that leftmost number. So let's see. I think it is -2.25. That's what I'm going to roll with. And of course here, I'll just extend this down so we stay consistent. Got a 0. So I need to find the area of the shaded region under the standard normal curve from negative 2.25 to 0. So here's what I'm finding. I'm going to write several iterations of this to show for understanding. So I'm looking for the probability that z falls between negative 2.25 and 0. Since 0 is in the middle and this is symmetric, I could also say, or I could also use this, the probability that z falls between 0 and 0. In other words, you could do it the other direction. You could say the probability that I turned my symbols around. That was really odd of me. It took me a second to figure out what I had done. 2.25. So you could also do this direction. So you could either look from one side that the z falls there or the other side. Now, why would you do that? I don't know. This is just for understanding. So you could use either direction here. So if I go on my calculator and go second vars, normal CDF, if I go from negative 2.25, comma, 0, I get that. If I go second enter and now go from 0, comma, to 2.25, I get that. It's going to be the same area. We're looking for the area underneath the curve, which equates to the probability in this normal distribution. So we could use either one of those. I could also, if I was just using the table, if I had no technology for a particular moment in time and I'm just using the table, I could also go find the area from here to negative infinity, find the area from here to negative infinity, and subtract those two. And that'll give me the area in between. So, really quick, I use my table. Oh, well, I know this is 0.5 because from negative infinity to 0 is 50% under that curve because that's the mean and the median. And wherever you have the median, you've got 50% of the data on one side, 50% on the other. That's what we've got. So really the only one I've got to find is negative 2.25. So what's the area to the left of negative 2.25? So there's 2.2. I look at the top for 5. 0.1222. Okay, so then I just take 0.5 subtract 0.01222. 48778. Is that what I got earlier? Yeah, it's right there above. Yeah, 48778. Yeah, good to go. So I checked it with the table and also checked it with the calculator. We're good to go. So I've done quite a few of these now. I'm going to try to skip to some other ones that are the same. I can't remember what my next one was. I'm not going to do that one. Let's go here. Yeah. The only reason I want to look at these is because they are just laid out differently, but they're the exact same thing that we're looking for. Let me switch color so it'll show up on the dark background. So find the indicated area under the standard normal curve. Find the indicated area, okay? If you're looking to the left of z equals 0.33, you're looking at the probability that z is less than 0.33. I'm going to write the syntax for the calculator. I don't necessarily need to work it out, but I may. Let me do a couple of these. So I've got normal, CDF, negative 10. Remember, that's just what we're using in class. 0.33. And what does that give me? I will just work it real quick. Second bars. Normal CDF, and I've got negative 10, comma, 0.33. Entree. So I got 62930. Point. So there's my answer for that one. So there it is. Okay. So Artemisia, back to your question a second ago, these are the kinds of things that I'm looking for. So when you have to the left of this, I would like to see it written as a probability. And then I'd like to see the syntax that you used, and then you can put the answer. In this next one, let me switch colors. To the left of z equals negative 1.675. So I'll just do 2 of these and I'll move on to the next. I think I've written some different ones. It's been a while since I brought this one up. So I'm looking at the probability that z is less than negative 1.675. And if anybody's still, Artemisia, if you're still here, if anybody's still there, this screen that I've got right here where I have my keynote presentation minimized and smaller and the calculator bigger, can you see this okay? Like, is this showing up okay? Just a yes or no, or I can see it okay, or if you don't mind, just give me a little bit of feedback. That helps me understand whether I need to try to make this bigger, make the calculator smaller, or how I need to superimpose this. I can even take that one with my presentation, put it in the entire background. That way I have more up and down space. So anyway, we've got this. Then I would use normal CDF. I would do negative 10 comma negative 1.675. Oops. Sorry, scratched out a little bit there. Clear second vars, normal CDF, and I've got negative 10 comma negative 1.675. And remember, we're working with a standard normal here. Not data, but just a standard normal. So 0.4696. There it is. All right, there's 2 of the 4 that I've worked. So again, these are the same things that I was doing with the graphical representation that I had in my presentation. The same thing. This is just written in words. It's the exact same. All right. I'm not going to do the last 2. They're set up the same. Now let's do these to the right of. So find the indicated area under the standard normal curve to the right. We'll do this one first. To the right of z equals negative 0.65. So to the right is this direction as I'm facing it. So it's going positive. So I'm looking for the probability, it is a standard normal, so that z is greater than negative 0.65. Okay. My far left is going to be negative 0.65, and then I'm going to go there. Okay. So I go normal CDF, negative 0.65, comma 10. And remember, the 10, negative 10 is just our arbitrary number from class. It pushes you out far enough that you're not going to lose at 100ths of a decimal place. You won't even lose to 1,000, really. You could go, remember I said 3.49 to negative 3.49. Typically, that's about 100% of the area underneath the curve. All right, and then I get, I don't know, let's see, second vars, normal CDF, and I've got negative 0.65, comma, 10, enter, it's already there, 74215. Here we go. There's that one. Thank you for the feedback. When I'm looking at it, of course it looks fine here on my screen, but I'm always curious how it looks. I can see it on my phone, and it looks okay there for me, and I don't have my glasses on, but I can still kind of see it. But I also wrote it, so I know what's on there. So it's kind of a jaded view. So thank you for the feedback. So there's one to the right. And let me just check one thing. Okay, yeah. Let me see what's my next one. Between 0, let's do at least one of these. Between 0 and z equals 2.86. Start with this one. Well, I'll do 2 of these just in setup. So find the indicated area under the standard normal curve. No problem. So what I'm looking for here is the probability that z falls between 0 and 2.86. All right. Again, when I use the, and I'm sticking a lot to the calculator. Again, I wish I had this up and I could walk through it with you. I really did a disservice for us by not bringing that up. But on the calculator, I'm just going to go between 0 and 2.86. So I'm going to go normal CDF, and I'm going to go 0, 2.86. Now, remember, this is from the middle point that I'm going out to 2.86. So I could also do this. Normal CDF. I could also go from negative 2.86 to 0, and that would be the same area underneath the curve. Hey, Gun Bunny, thanks for stopping by, buddy. That would be the same area underneath the curve from negative 2.86 to 0 as it is from 0 to 2.86. Now, let me go over here real quick, and I'm going to work on the calculator. What happens if you turn this around? Like, what happens on the calculator if you go normal CDF, and you're thinking in your head, symmetrically this is the same, so I could switch the numbers up. And instead of switching it up like I did from the negative to the 0, you put this, 2.86 to 0, thinking that it's going to be the exact same. Well, how does the calculator react to that? Second vars, normal CDF, and in this case, what did I say? 2.86, comma 0. So again, the calculator's looking from left to right. It gives us a negative area. That doesn't exist. It's positive areas. So if I go back and I work it correctly, and my calculator here is a little bit different. This one is 0, 2.86. Still gives you the same thing on my calculator, but I can't remember. Let me work it on mine. I thought it gave you an error on here. Maybe I'm just getting older and dreaming stuff. Normal CDF, if I go 2.86, comma 0. No, it gives you a negative. So anyway, you see what you come back with. Now, you can't write negative 0.497881. I mean, you can. But if you write that for the answer, it's wrong, because there's not a negative area underneath this curve. However, the only thing you've done is switched up the numbers. I switched them up here, but if you remember, I used a negative. I went from negative 2.86 on the curve to 0, so I'm still in the right with what I get for an answer. If you do it this way, you would still be in the right, but you just have to remember that it's not a negative number. It's a positive because it's an area underneath the curve. Okay. Let me do at least one more of these. I've been on here, I typically say about 45 minutes, and I've been on here about 41 minutes. So let me work through just a couple more. Very simple one here with z-scores, which is what we're going to have to work into when we work with x values. When we have just a normal distribution and not a standard normal. So this is find the z-score that corresponds to each value and determine if any are unusual. The test scores for the Stanford-Binet intelligence scale are normally distributed with a mean score of 100, right? And a standard deviation of 16. No problem. This is kind of what we were doing last night. The test scores of 4 students selected at random are 98, 65, 106, and 124. Find the z-score that corresponds to each value. Okay. The z-score equals, start with this one, 98, x subtract the mean divided by the standard deviation. So the first one would be z equals 98, subtract the mean of 100, which was given, divided by 16. There's your z-score. You just have to finish it out. So it would be 98, subtract 100, divided by 16. Negative 0.125. So there's one z-score. And then you go for another one. Let's go with, that was for 98. Now let's go for 65. And you just got 65 subtract 100 divided by 16. Blah, yada, yada. Finding the z-score. Because if you can't find the z-score, then when you're given a regular standard normal, you won't be able to map those down to your standard normal distribution. If you can't map it down to the standard normal, then there are other, you can use the calculator if you haven't mapped it, by the way. But the way we're working in a class, you can't, because we're only going from z-score to z-score with those two numbers. And if you want to use the table, you're not able to use the table for those x values because you don't have a table for every possible mean and standard deviation, but you do have one table for the standard normal distribution, which you can map every normal to. Hope that helps. Made sense in my head. All right. What do I got next? Find the z-score that corresponds, determine if any unusual, find the indicated probability of the standard normal distribution. Okay, so this, what I had here was just more of the same, just different type syntax on this, on the way this is set up. And then you go here. That's supposed to be a dynamic. Doesn't seem to be dynamic. If I go done, there it is. The beauty of Keynote. What a great presentation. I've got stuff moving in the background. All right. I think I'll leave it right there. This gives me a little bit of room to continue working next week. But I hope this helps a little bit just to extend what we did in class last night. Excuse me. We worked in class last night on the first day of normal distributions, although your understanding of the normal curve, at least property-wise, from studying the empirical rule and knowing the empirical rule information, helped us get started into that last night. We worked with using the table to find areas underneath the curve, hence probabilities. We worked with using the calculator, and I drew fancy pictures, and we learned different ways to skin that cat, so to speak. That's the way I said it. Normal curve can be confusing because it takes a little while sometimes to get used to the table. Once you get used to it, it's like riding a bike. It's very easy. You just go right back to it every time. And another part of normal curves that sometimes is confusing is that you can approach different, you saw me even just in the simple examples I was doing, approaching the problem from different directions. In this one I did it this way, in this one I did it this way. They all came out to be the same number. So from a student standpoint, it's no longer Algebra 1 where you're just setting it up, doing it, everybody does the same thing. You could go into it from different directions, which you can in Algebra 2. But you're going in at different directions and coming out with the same answer for probability. So, but I think that's where I'll close for tonight. Gun Bunny, appreciate you showing up, man. Artemisia, thanks for stopping by. I appreciate the feedback on at least the screen. I'm still trying to get this straight, and of course I hadn't been on in a week or so, so I haven't adjusted anything. I like Ecamm's layout. I may go with Restream. I may do a Restream this weekend. Just put a video on demand out there just for giggles, and I will extend into some of these other problems I didn't do, so that'll be out there for you. And then next Tuesday, I will talk about normals if nobody has questions on binomials, but I'll be glad to talk about binomials because I know some folks might like some points back on their test, given that we struggled a little bit with the binomial, building the binomial distribution that I had on there. So, okay. That's what I've got. I've enjoyed being here. I like doing this, open office hours for my statistics course, and I appreciate any students that come by and anybody else that stops by. I've only had one night where I had a whole bunch of people stop by. But that was kind of fun, so I'd like to get back to that. So we'll see if we can get maybe some folks from around the world again stopping by and maybe asking questions. So Artemisia, thanks. Gun Bunny, thanks. And I will see you guys later.